Hello, in this video I will showcase Q²Forge resource, our end-to-end pipeline to generate a dataset, a question and SPARQL query pairs for a given knowledge graph. Here I'm going to use a local version. However, note that there is an online version in this URI, and the two repos, so the front end and the back end, are open source, and you can get them in those two repos. So to install them locally, it's quite simple. You have two commands to run. One to install the dependencies or the environment, the Conda environment, and the second to launch the app. There is also a API documentation if you need it. So let's jump into it. So here we have the diagram for the resource. As you can see, the pipeline, we are saying that it's an end-to-end pipeline since it's composed of different tasks, and you can use the tasks separately, or you can use it, you can use all of them at once. So we have first, given a knowledge graph, we want to create questions, competency questions for such knowledge graph, or maybe we have just few. However, we can, with our resource, we can create even more, so much more. And once we have those competency questions, we can try to generate and propose SPARQL query equivalents. So first step, we have a knowledge graph. We create a config for this knowledge graph. We can extract a schema for this knowledge graph. We generate some competency questions. We can use the pipeline just for generating new competency questions. And then you can export those competency questions and use other systems to generate equivalent SPARQL queries or answer those competency questions. Or we can continue and we can use the second task, which is to propose SPARQL query equivalent for those competency questions that were generated. If you use another competency question generator, so not our system but another one, you can import them into our system and use it starting from this point. Once the competency questions created, then we can answer those. We can propose SPARQL query equivalent. We can interpret the results at the end. Once we have those SPARQL queries, we can use them to query some KGs. And since here we are using large language model to propose such SPARQL queries, they might need some refinements. So this is the third task. So to refine SPARQL queries with the judging and refinement query. If you have some SPARQL queries and you want to refine them, you can use only the third task. So you can come with your SPARQL queries and you can try to refine them using our tool. So once you have refined your SPARQL queries, so you have the questions, you have the SPARQL query, so you can create the Q2 set. So the question SPARQL query pairs. You can create this Q2 set and then you can export it. You can use it for benchmarking, for training and testing other models, and so on. So this is the main and global idea of Q²Forge. Now we will see each part. Here you can navigate to different parts. So we can start with KG configuration and creation. So click here. Up. So here we need to give information about this new KG that we want to create. So I will just copy paste some information. So for instance, this is a new KG, so we can give the full name, then we can provide a short name. So you have tooltips for each field to show you what it's used for. For instance, the short name, it's used in the file path in the backend. Then we will give a description, the endpoint where we get the data, and where we can find the ontologies, because sometimes the ontologies are not loaded in the same KG. So here you can put the other endpoint if you have one. In the prefixes, here we provide all the prefixes that are used in our KG. Here, just by start typing the prefix, you have the auto completion. If it's a prefix that is available in the prefix.cc, and we do it for all the prefixes, also for the ontologies. And here we give some query examples. Since here we are using to come up with the to propose the SPARQL queries for a given competency question, we are using Gen2KG bot. Gen2KG bot propose different scenarios that you can find them in the homepage. So here we describe each of the scenarios, from the basic one that given a question we answer the question directly with an LLM call, to generating the SPARQL query, doing some pre-processing, and so on. So in starting from scenario 6, we will use some SPARQL query examples to aid the LLM to get more context and to understand the patterns used in the KG. So if you have some examples of competency question and SPARQL query, you can provide them here. So the question and the SPARQL query. Or if you don't have any, what you can do, you can start with no query examples. Use our tool to come up with competency questions, generate SPARQL queries, refine them, and then use those refined SPARQL queries and competency questions as examples to be able to use scenario 6, 7, and so on. So here I will do some magic to fill up the fields. Since I'm using it locally, I will just do a little sleight of hand. So this is what will look like the configuration after filling it up with all the information. Once this is done, we can click on create configuration. We have a message that the configuration was created successfully. We can go next. So here we will activate this configuration to be the active used KG. Then we will generate descriptions for the KG. So for instance, here we are describing the used classes with the label and description and the properties, and we're doing some sampling to see how the classes and properties are used by the instances in the KG. This is used in RAG system in different scenarios. So retriever augmented generation. So we will do some RAG given those descriptions to aid the LLM to generate better queries. And do next, and here we will generate the embedding. So in the backend we are generating the embedding, so it was successful. And since our KG is not big, the embedding didn't take long. However, if your KG is big, it means that you need to wait a little bit before the embedding finished. And we are good. So now we can go back to the competency question generation. So this is the second part. So here we are starting the 3 main tasks after creating the configuration for our KG. So if you did this part previously, so the description, the schemas that are used are filled automatically in the context for the URI. Here you can, it's free fill to give additional information to better aid the large language model to come up with some better competency questions. So here you can select the model to use and the number of questions to generate. Here you can enforce the structured output, meaning that we will have a structured JSON output that can be used in the subsequent tasks. So this is required if we want to have structured output to use it afterward. So note that if you use not a performant knowledge graph, large language model, or if it is not, if it do not support structured output, it won't work always. So here I will try to use a good model. So let's go with O3 mini. I will generate questions. The task is starting, and here we will have the answer. As you can see, it's proper JSON. We have the highlighting. For each question, we will have the question, we will have its complexity, and some tags. So here we have 10 questions. Here you can either download the dump answer, so the answer as it was produced by the LLM, because sometimes you have the questions and you have additional information that was provided by the LLM, or you can just extract and download the this part as the questions as JSON, or if you want to use the other tasks of the pipeline to come up with SPARQL queries that are equivalent to those questions, you need to click on this third button to save them in a cookie and start to answer the questions. So here, if we check the current questions, we can find all the questions that were generated. We can export them in different formats if we want to use them in other systems. And you can here delete some if you think they are not relevant. I will close this one. Here you can drop a JSON file following the same schema that was generated in the first task. And you can import the questions here directly to use them in the system. Or you can here, you can ask the question yourself. You can type it. Here, all the questions that are in the cookie that are saved are here filled automatically, and you can it's filtering it on the fly. If I can check one question that we can use, so I can use this. Which wheat variety are most frequently mentioned in so I can use this one. Here, once we have the question, we can configure the scenario that we want to use. Because as I said, Q²Forge support different scenarios. So here we can click on this configuration button, and we can start the configuration. Here we can select the scenario that we want to use. When we select the scenario, here on the right we have a mermaid schema of that scenario. So and as you can see here, we can define which LLM we will use in different parts of the scenario. So for instance, in scenario 1, we use the LLM to validate the question, and we use the LLM to answer the question. So we can select which LLM to use in different parts. So we can use different LLMs in different parts. So for instance, if we go to scenario 5, so here we have to validate the question, to generate the query, to interpret the query, and what is the embedded model to use. Now if we go to scenario 6, and I can try to use, let's say, Gmadjust 3 4B, and it is local for validation. And let's use O3 mini for the rest. For this, I will keep it as default. So here you can see the used configuration if you need to. Once it's done, we can close, and we can launch the process. So here we have a chat message thread like system. So on the right we have the user message, or the question that is asked, and on the left we have the all the trace of the workflow, meaning it's transparent. For instance, here we have the question. We start here, we said that we are using the scenario 6. We validate the question. Here, when it's green, it means that we are doing an LLM call here. And here you have also in the title the LLM model that was used in this particular node. So for instance, the validation is deemed related to the knowledge graph. If we ask an unrelated question, here it will not pass this filtering phase. We do pre-processing. So here we are using spaCy to select only to do named entity recognition. We select the similar questions, SPARQL query examples. So by default we are extracting 3. If we continue, we are selecting the similar classes. Then for each of the classes we are selecting its context from the KG. and then we are prompting the LLM to generate a SPARQL query. So here we generated this SPARQL query. Here we are verifying the query if it is valid or not. Valid means syntactically correct. And then we are trying to run the query. Here we are mentioning that there was no results when running this query. Since we are using scenario 6, we are just making a syntactic verification. However, if we go back and we select scenario 7, for instance, for scenario 7 we have also LLM as a judge part, where here we can use, for instance, let's use O3 mini also in both, or to showcase this in the first generation I will use a smaller model. So I will use, for instance, here Gima 1b to show you that usually the SPARQL query that would be generated would not be syntactically correct. Then when we iterate, we will create a better query. So launching the workflow. Once again, we have the same question. The question is valid. We pre-processed the question once again. Here, if you see, we are loading the context from the cache, while in the first question we loaded the context from the KG, because it was the first time we are extracting those classes. So this is the goal of the caching mechanism. Over time, we will not query the knowledge graph for the context, so we will accumulate it over time. So now we generate the query with Gima. When we validate it syntactically, we can see that it is invalid. So here we are trying to prompt LLM to regenerate it, giving it also the cause of the failure. And here we are using O3 mini for this second iteration. So this would be a better query, we hope. If we check the validation of the SPARQL query, we see that it is syntactically correct. In this scenario, we extract the Q names, so the qualified names and fully qualified names from the SPARQL query, and we feed it to an LLM as a judge. So here the judge stated that it is mainly correct. So it gave a grade of 8. And we can define the threshold to accept SPARQL query or not. So if the threshold was 9, for instance, by default it's 8. So if we put it at 9, so we will iterate to come up with another SPARQL query up to a maximum number of retries. For instance, by default it's 3. However, you can modify it in the configuration. So once again, when running the query, here also the query was empty result. So meaning that we might need to refine the SPARQL query. So to refine the SPARQL query, if we go up, once the process is done, we iterate over all the message thread, and we check the messages that were generated by a model, a large language model, and we check if we can find a SPARQL query in that message. If so, we will add this refine query button here. If we click on this button, we will jump to the third part of our task, to refine a SPARQL query. So we click here, we jump to the third part, so this SPARQL query refinement. We put the question, it's pre-filled. The same with the SPARQL query. Here, to refine the SPARQL query, we will extract the Q names and fully qualified names. I will take another example just to showcase this part. So here, since we are using YasGUI editor, so if for instance we didn't have some of the prefixes, here we can use the pre-built functionality. And if you already defined the KG configuration in the first step, you can add the known prefixes by clicking on this button. So it will add all the predefined prefixes. You can run the SPARQL query on a knowledge graph to check the information. Here you can extract the Q names from the SPARQL query, qualified names and fully qualified names. For instance, here we will have two. We'll have E, so an RDF type, and the Fabio research paper. And we can get its context. So if we click here, so we extracted the qualified names and fully qualified names. However, we were not able to get the info. We have an error message. This is because this SPARQL query do not accept external queries. So if you have the knowledge, the ontologies in another knowledge graph, so you can put it here. For instance, if I will use this one, here I will not have the data. However, I will have the ontology. So if I can get the context, so here I'm getting the information about those qualified names and fully qualified names that were used in the query. And I'm getting all the context using those properties. Here you can add other properties if you want to. So here, for instance, if I delete this one and I click again, so I will get only the label. If I add it back, so I will get also the comment. Then, given for instance here, this question is getting, for instance, all the 10 of the research papers in this knowledge graph. So I can, if the question was what are or give me 50 research papers in the KG. I will do just this. So if this was the question. I can put the question, the SPARQL query. Here it was 50. However, I'm limiting at 10. So when using an LLM as a judge, we hope that we will get this information to be able to refine this SPARQL query. So once again, I will use O3 Mini. When using the judge question and query, so here we are having the grade of 7, and the justification is that the query correctly identifies the research papers using the Fabio and the prefixes. However, for the question requires 50 research questions, but the query uses limit 10. This doesn't meet the requirement due to this mismatch, so the overall query is incomplete. This is why we get the grade of 7. So if I change this from 10 to 50, as it was requested by the LLM, if I now try to do another judging, so now the grade is 10, and the justification is that it's mainly correct. So here in this part, you can come up with your questions with your SPARQL query, and you can use just this part to refine the SPARQL queries without using the other tasks. So as you can see, each of the different features can be used separately or can be used in a full pipeline. So once, if I go back in the to the final task, so once we have the questions, for instance, let's say we had this question, give me 50 research papers in the KG. We can add this pair, so this question and SPARQL query, to the dataset. So if we want, we can even go and clean the unused prefixes. Once we are satisfied by the query, we can click on this add to dataset. When we click on it, we are adding it to the dataset. Once we accumulate the whole dataset, for instance, now we have just one. Once you have the dataset that you want to export, then you can export the such dataset using different format. For instance, if we can choose CSV, we can export this dataset. I will use this same name. I will replace it. And if I go back to this file, so here we have the question and query pair in a dataset that can be used in other workflows. So this was Q²Forge. Thank you for your attention, and bye.